So welcome to GMST Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 7. So voltage regulation of alternator by EMF and MMF method. So aim of the experiment is to determine the voltage regulation by EMF and EMF methods by conducting the open circuit and short circuit test on a given alternator. So these are the apparatus required. We require the digital ammeter, voltmeter, rheostat, TVST switch, motor as well as the synchronous machines. So that is alternators. So this is about the theory. Regulation of alternator by EMF methods, which refers to the ability of alternator to maintain the constant terminal voltage as the load varies. It is commonly expressed as a percentage and it can be calculated using the several methods. So one which we are going to use the EMF method, which is also called as a synchronous impedance method. It is a theoretical approach to determine the VR, that is voltage regulation of alternator under the various load conditions. So this is actually the circuit diagrams. So here we are going to use the motor as well as the synchronous machine, that is alternators. So we have to provide the DC supply which is connected to the 3-point starter. From the 3-point starter we are connecting the armature and the field of the motor. So this motor is coupled to the synchronous machine, that is alternators. Then for the excitations we are using the field excitation for the synchronous generator, where we have to provide the DC supply. Across R and B we are going to measure the voltage, that is the 3-phase voltages after making the excitations. And here we are using an ammeter to measure the what is the current. Then we have the switch. So procedure, when you talk about the procedure, we have to conduct the open circuit test. That is the connections we have to make according to the given circuit diagram. The field resistor of a DC motor is kept in a cutout positions initially, and field resistor of alternator should be in the cutting positions. Next, the supply is given to the DC motor by closing the switch. The DC motor is started. Now motor, we have to bring the motor to the rated speed so that the synchronous of the machines can be synchronized where the motor and the alternators can run at the same speeds. So by making the cutting positions of the motor field rheostat. So then DPST switch to, we are using DPST switch where you have to excite the field of the alternators. The resistor of the alternator should be kept, field should be kept in the cutout position gradually. Then in step by step and corresponding the field current should be noted on for the open circuit voltage of the alternators. And these readings has to be tabulated, which we have shown in the videos also. Next, the field resistor of the alternator is brought back to the original position, that is the cutting positions. So for conducting the short circuit test, the TVC switch is closed so that the stator terminals should be shorted. That is, any two of these stator terminals should be shorted, that is R phase and Y phase. The field resistor of the alternator is cut out gradually in steps till the rated armature current is obtained. Then the armature current IA and corresponding the field current are noted down. The field resistor of alternator is brought back to the cutting position and DPST switch is open. So armature rheostat, the field resistor of the motor is brought back to the original position. Then we have to switch off the supply. So then we have to measure the DC resistance per phase of the stator, which is measured according to the by a method called voltage meter method, that is VA methods. So this is the tabulations, we have to note on the readings. These are the calculations, we have to find out the RA using the VA methods. ZAC, that is the synchronous impedance VAC by AC. XS we have to find out. For the EMF we are using this formula. V0 is equal to under the square root of V cos phi plus IA RA whole square plus V sin phi plus IA XS whole square. This is the regulation formula, EP E0 minus V page divided V page into 100. So here we have to tabulate the regulations for the lead and the lag for different various power factors, that is 0.2, 0.4, 0.6, 0.8 and 1. So this is the expected graph where you can see the OCC curve and SCC curve from the given tabulated values, where they have plotted the graph for the field contours of the voltage, and this is the regulations graph. Finally, when you come to the result, alternator is the regulation of the alternator is obtained by EMF methods by using the OC and AC test, and we have to plot the regulation of the power factor. Thank you. So today we are going to study the voltage regulation by EMF method. So this is actually the circuit diagrams. You can see there is a starter, motor and the alternators. So with the help of this setup we are going to check the EMF methods for the voltage regulations of the alternators. So this is the rheostat. We have to keep the rheostat in the cutout positions. This is the field rheostat, and this is the rheostat for the alternators field. This should be in the cutting position. Right. So as per the given circuit diagram, after making the connections, you have to close the switch. So once you close the switch, keep the 3-point starter in the on position. Now we have to take the readings for EMF method. We have to take the readings for the IF for the open circuit voltage. We have to vary this Now you have to vary the rheostat of the alternator field windings until we get the rated voltage, that is 440 voltages. You can observe that the voltage is getting varied. Vary the rheostat until you get the rated voltage of 415 or 420. Okay. Now we have to take the readings of this speed, that is 15644, and the voltage is 216. Now again we have to bring back the rheostat to the original position, that is in the cut-in position. Close the switch. Thank you so much.